Okay, today we're going to take another look at inequalities, specifically graphing these inequalities on a number line. Now, I know you guys looked at this last year, so hopefully this is just a review for you today. We just said that an equation is a mathematical sentence that sets two quantities equal to one another. It says that these two quantities are the same. So with that in mind, that's what an equation is. What do we think an inequality would be? You're on the right track. You're halfway there. Okay, think about this, guys. Hands down. Think. Okay, turn your brains on and think. An equation equals says that these two quantities are equal to one another. An inequality takes those two quantities and says that they are not equal to one another. So an inequality would be a mathematical sentence that sets or says two quantities are not equal. Okay, absolutely, positively, 100% not equal to one another. Now we have some symbols that we use for inequalities. In fact, we have 5. All 5 of them are on this poster over here. And I know that you guys have seen at least 4 of them before. Can you pick out which symbols on here are your inequality symbols? Can you give me one? Not percent. Is less than. Okay? Can you give me another one? Okay. Is not equal to. Is greater than. Less than or equal to. Is greater than or equal to. Now, I know someone's sitting out there thinking, but an inequality is not equal to. Those two include equal to. True, but it says less than or equal to. Greater than or equal to. Okay? So those are the symbols that we use. Now, this one, guys, we'll come back to this one later. We'll see that one more in Algebra 1 and Algebra 2. Okay, we want to focus on these 4. Okay, less than, greater than, less than or equal to, greater than or equal to. Okay, now, the solution to an equation, think about those 3 equations on the starters. What did all 3 of those solutions look like? What did you circle? Give me an example of something that you circled. Okay, and what did that answer look like? Variable equals number. X equals 5. 18 equals Y. Okay? That's what the solution to an equation looks like. Okay? It's a single number. Okay, the solution to an equation is a single number. What would that look like on a number line? Okay, we had x equals 5. That was our answer to number 1. What would that look like on a number line? If I ask you to show me x equals 5 on a number line, what would you do? Okay? And you would just put a point at 5. Okay? The solution to an equation is represented by a point on the number line. But the solution to an inequality is a little bit different. It's not just x equals 5. Okay, we might have, for instance, x is greater than 5. Okay, for our solution for those equations, there was only one number that made that equation true. Anything else, if we subbed it in place of x, the equation wasn't true. But I'll bet we've got 20 students in here right now. I bet each of you could come up with examples that makes that true. Okay? Could you give me a number that makes this inequality true? 6. 6 is greater than 5. Can you give me another one? something else that's greater than 5? 10 is greater than 5. 21 is greater than 5. 100. Now we're having fun. 56. 7. 1,000. 80 bajillion, 422 quadrillion. Okay, we can make up some giant number, and that's greater than 5. Okay, but there's a lot of solutions that fit that. So it's not just a single number, and it's not even a list of numbers. Okay, it's a whole range of numbers. A whole range of values. A whole range of values that's greater than 5. Now, if I wanted you to show me that on a number line, okay, I wanted you to show me x is greater than 5 on a number line. Okay, so we've got a number line. Here's 0, here's 5. Okay, someone said 6, so I could put a point at 6. Someone said 7, so I could put a point at 7. We had 8, we had 10. We had a whole bunch of really big numbers, so I'll just shade in this arrow part. Okay, that'll take care of all the big numbers. Okay, but what about the numbers between 6 and 7, like 6.5, 6 3/4, 6 1/8? Are those all greater than 5? Yeah. So tell you what, we'll shade in all those gaps between those points, because if I shaded in all those points, they would just overlap, right? Okay, what about like 5 1/2? Does 5 1/2 work? Okay. What about like 5 1/4? Okay. What about like 5 1/10? What about 5 1,000? What about 5.0000001? Yes. Okay. So the point is, I can get really, really close to that 5, but not that 5. Okay. So what I need to do is I need to represent this by a shaded region. On that number line. And look what we did. Okay, when we plotted all those points, they overlapped, and eventually we just had a big shaded region on that number line. Well, that's what we're going to do. Okay, but there's something else that we need to talk about, because I still haven't really graphed everything yet. There's all those numbers that are just slightly bigger than 5, and I need to graph all of those. So there's two parts to how we graph this inequality. Okay, the first one is the direction that we shade. Or I should say the second one is the direction where we shade. Okay, and we kind of saw that one already. Okay, we'll talk a little bit more in detail about it. But the other part has to do with the circle. Okay, I'm going to put a circle at that 5. Okay, because I know that my inequality starts at that 5. It starts at that 5, and I shade everything to the right of it. Okay, but the question becomes, what kind of circle should I use? Because I want to represent numbers that are really, really close to that 5, but not the 5 itself. Okay? And we already said I can't just start at 6, because there's like 5 1/2 and 5 1/4 works. And I can't start at like 5.1, because 5.01 works, 5.001 works. So I can't start at any of those numbers. So what I have to do is somehow include a circle at that 5. But if I shade that circle in, what that graph is saying is that 5 is part of my solution. If I put 5 in place of x, is that inequality true? Is 5 greater than 5? No. So what I'm going to do, if the inequality that we use is greater than or less than, just greater than or just less than, we're going to use an open circle. Okay, we put a circle at that number, but we don't shade it in. And that says that we can get really, really close to that number, but we don't include it. Okay, any number that's really, really close to 5, just as long as it's bigger, but not 5 itself. Okay, but if I change that around, and I make it greater than or equal to, or less than or equal to, now, would that 5 be part of my solution set? If I put this little or equal to, is 5 greater than or equal to 5? Yeah. So if I have greater than or equal to, or less than or equal to, we're going to use a closed circle. We'll shade that circle in because that circle, that number, is now part of my solution set. Okay? So I've got the circle taken care of. I know where I'm going to start. Now I need to talk about which direction to shade. Okay, now there's a lot of traps that students fall into. They want to say, well, whatever direction the inequality points, that's where we shade. Or if it's greater than, we're going to shade to the right. Those work sometimes, but not necessarily all the time. Here's a trick that will work all the time. I want you guys to think back to when you first learned about inequalities, okay, and you had like 3 and 5, and you had to say which one was greater. Okay, you had the alligator eating the bigger number, right? Do you remember that? Or maybe it was the Pac-Man was eating the bigger number, or the hippopotamus, but something was eating the bigger number, right? Okay, now, let's say that right here I've got Jake and Mark, okay, and I have the alligators eating Mark, okay? That means Mark's bigger, right? Well, if Mark's the variable, okay, and I want to shade where the bigger marks are, where are the bigger numbers on a number line?
To the right.
To the right. So, if the inequality, and guys, just like I abbreviate equations, EQs, I'm going to abbreviate inequalities in EQ. If the inequality opens to the variable, okay, meaning that the alligator's eating the variable, okay, that means that the variable is the bigger number. And I need to shade where the bigger numbers are. So we'll shade to the right. Now on the other side of that coin, let's say this time Mark's still the variable, but now the alligator's not eating Mark. It's got its back to Mark. Okay, that means that Mark is the smaller value. Well, where are the smaller values? On a number line, where are the smaller values, guys?
To the left.
To the left. So that's where we'd shade. So if the inequality points to the variable, we'll shade to the left. Okay, if it opens to the variable, we want the big values. Big values are on the right. If it points to the variable, we want the smaller values. Smaller values are on the left. Okay, now, I want to take a look at some examples. Okay? So we'll keep that chart in mind. And in fact, I have this for you. I'll put this up over here. Okay, you guys have your chart on your notes. I've got mine up over here. All right, and we'll look at these 6. So, I have x is greater than 4. Example 1, I have x is greater than 4. First, I want to think about the circle. Should it be open or closed? Then I want to think about which direction to shade. So, I'll start with my number line. 0 near the middle. And here's 4. Now, this is just greater than. X is greater than 4. So I look over here, greater than. And I see if we're using greater than, then we use an open circle. So my circle on that 4 is going to be open. We'll draw an open circle at that 4. Then I want to think about where to shade. Okay? Well, this inequality opens to x, which means x is the big values. So I need to shade where the big values are. That's on the right. So when we shade to the right, guys, we shade all the way. to the right, all the way to and including that arrow. Okay, that means everything to the right of that 5, or that 4, is going to be in our solution set. Okay, but we keep that circle open, okay, because that 4 is not part of our answer. Okay, number 2, I've got 5 is greater than or equal to y. So we'll sketch a number line, we'll get it ready, have our 0 near the middle. There's 5. First thing I want to think about is that circle. Should the circle be open or closed? Well, I see greater than or equal to. And if they use greater than or equal to, we're going to use this closed circle. So I'll put my circle at 5, and I'll shade it in. Okay, then I want to think about the shading. Which direction should I shade? Well, does that inequality open to y, or does it point to y? Which one is it?
It's open.
To y?
Oh.
It points to y. Okay? This inequality points to y, which means that we want the little y's. So we have to shade where the little y's are. Those are on the left. So we'll shade to the left. And we'll shade all the way to the left, all the way to and including this arrow over here. Okay, let's take a look at number 3. I've got z is less than negative 7. So we'll sketch the number line to get it ready. 0 near the middle, and negative 7 over on the left. Now I want to think about that circle, whether that circle should be open or closed. Well, I see less than. Z is less than negative 7. And if they're using is less than, we use an open circle. So I'll put an open circle on that negative 7. I will not fill it in. Now I want to think about which direction to shade. Okay, so I look over at this part of the chart, and I see that inequality is pointing to z. Okay, the alligator's eating the 7, or the negative 7. It's pointing to that z, which means that the variable is the small value. So I need to shade where the small values are, which is over on the left again. So we'll shade all the way to and including that arrow on the left side. So z is less than negative 7. I have an open circle at negative 7, and I shade to the left. Okay? Let's do one more. So I've got a is less than negative 20. So number line, 0 near the middle, negative 20 over here on the left. Okay, let's talk about the shading. I see less than. And what does that chart tell us if the inequality that they use is less than? What kind of circle are we going to use? An open circle. Good. So I'll put an open circle on that negative 20, and no matter what, I don't shade it in. Okay, now I need to think about which direction to shade. Okay, well think about this. The alligator eats the bigger number. Is it eating the A, or is it pointing to the A? Eating to that A, is he eating that A or pointing to that A? It's pointing to that A. So does that mean that A is big or little? It's little. And where are the little numbers? To the left. So that's where we shade. All the way to the left. Okay? All right. What questions, bless you, what questions do we have on any of those 4? Questions do we have on any of those 4? All right. It's pointing to the variable. Okay? Now remember, it all comes down to what you learned forever ago. Okay, the alligator eats the bigger number. That's why I keep saying it. Okay, so alligator eats the bigger number, right? So that means between these two, between Shane and Jake, which one's the bigger number? Shane's the bigger number. Okay? Now if Shane's the variable, that means that I need to represent where the bigger numbers are. And where are the bigger numbers? To the right. Okay? Now Shane's still the variable. Okay? Now the inequality is pointing to him. Okay? Which one's bigger? Jacob's bigger. So Shane is now the small numbers. Where are the small numbers? To the left. What we're doing, guys, is we're representing on a number line everywhere that our answers are. And any number that's in this shaded region will make that inequality true. Okay? Anywhere, so on number 2 here, any number in this shaded region is going to fit into this inequality. So if I pick, say, 4, okay, is 5 greater than or equal to 4? Yeah. -6. Is 5 greater than or equal to -6? Yeah. That's the point of this shaded region. Okay, it tells us anything in there is going to fit. Anything in there is going to work. Okay? Okay, so let's look at this next one. I've got -1/2 is less than or equal to b. So, number line, 0. Here's -1/2. Okay, first thing I want to think about is the circle. Should it be an open circle or a closed circle? Well, I see less than or equal to. What does our chart say about less than or equal to? Closed circle. So I'm going to close that circle on -1/2. Okay? Then I want to think about the shading. Well, is that inequality open to B, or is it pointing to B? Open to B, or is it pointing to B? It's open to B. So, does that mean that B is the bigger value or the little value? The bigger value. And where are the bigger values? On the right. So that's where we shade. Okay, and we shade all the way to the right. Okay, nice and dark, so there's no question about which direction we're shading. Okay? Okay, how about number 6? I've got C is greater than or equal to 18. 0. Here's 18. Okay, what do we think about the circle? Why closed? Or equal to. Greater than or equal to means that that 18 is part of my solution. So I want to shade it in. Okay? What about the shading? What about the shading? Is that inequality open to C or point to C? Yeah, you. It's open, okay? Which means, is C bigger or smaller? And where are the big numbers? On the right. So that's where we shade. All right, so what it comes to, guys, is this chart. If we're using greater than or less than, just greater than, just less than, we use an open circle. If it's greater than or equal to, less than or equal to, we use a closed circle because that number is part of our solution. If the inequality opens to the variable, we want the big numbers, we shade to the right. If the inequality points to the variable, we want the little numbers, we'll shade to the left.